Right, okay, so the first topic here, it's not a very difficult topic, it's more really for revision, but it's something that you all would have done at some point. Even if you've only done up to middle school maths, this first topic here is basic enough that I'm confident that everybody here has done it. And if you think you haven't done it, it just means you don't remember it. Okay, so you have done this. So the first topic here we're going to look at is linear equations. Okay, now, does anybody know what the word linear means to begin with, actually? And kind of the key to the definition is actually in the word itself, yeah?
Line.
Yeah, it just means line. So if you look here at the word linear, in fact, you can see the meaning inside the word. So linear equation just means really an equation of a straight line. But we'll talk more about that in a couple of classes when we do graphs. But for us right now, another meaning of the word linear equation means that the x has no power. So for example, this here would be a linear equation. Something like mx plus c. Because you can see here that the x, it has no power. Now if you don't know what power is, power means this piece up the top here. That's the power piece. Okay, so this is all vocabulary that I would like you to write down. So the piece up the top here is called the power. Okay, or there's different words for it too, but the one I use most often is the power. There's another word for it too. Does anybody know it? Instead of power, there's another word you can use.
Degree.
Yeah, actually degree would be one as well, yeah. Anything else? Yeah, indices, index, yeah. I don't really use that one so often. Probably power and degree would be the most common. But again, I wouldn't use degree that much because degree comes up in another chapter. What chapter do you think I'm talking about where you would hear the word degree?
Angles.
Angles, yeah. So I'll try not to use degrees because I'll just try and use a unique word for each topic. Okay? So yeah, degrees would come up in angles. So I'll stick to using powers. So if it's linear, that means the power equals 1. Or in other words, you don't write any power. So that's all fine and straightforward to begin with. What we're going to look at for the first class is just a little bit of a revision of solving linear equations, okay? So let's take our first example. So for example, I want to solve this one here. Let's say now, probably remember the procedure, but just to refresh your memory, first thing you should do is take the 1 over to the right and it'll become minus 1, and you'll get 3x equal 6 then. And then the second thing to do, divide by 3, so the 3 goes underneath there and you have your answer 2. Okay, that eases into the course nice and easy as your first example. Let's move on to one a bit more difficult. I'll just give you a few seconds to write this down if you haven't got it all down yet. Okay. I'll go down a little bit here for the next example. Now that one was straightforward enough, partly because the x just appeared in it one time at one side. But let's look at one a little bit more difficult. 2x equals minus 3x plus 5. Now it's really not much more difficult, but there's just an extra step involved. What we should do first is take the 3x or the minus 3x over to the left. So it becomes 2x plus 3x, which would be 5x. And here we can keep the 5 on the right. And then just like before, divide by 5. So we have our answer x equals 1. And also, you know, don't forget, if you're in an exam or something, you can always check your answer. You know, if I put x equals 1 back into this, it should be true. So for example, 2 times 1 equals minus 3 times 1 plus 5. Well, 2 times 1 is 2, and of course minus 3 plus 5 is 2 also, so it is true. Okay, again, I'll just give you a few seconds to write that down and we'll move on to a more difficult one. Okay. Now, next example, there's really 2 ways to do it. So, okay, firstly now, minus 5 over 7 x minus 2 over 3 equals minus 5 over 6 x minus 3 over 2. There's 2 ways to do it, but can anybody give me a suggestion about one way I could do it? Yeah?
First thing, you move the x's to one side
Mm-hmm.
and move the numbers.
Yep. That was actually the second way I was thinking of doing it. So we'll do that in a moment. I'm trying to think, or can anybody see another way of doing it? And what I'm looking for here, or let me ask you this, what's making this problem different to the last problem?
Fractions.
The fractions, very good, yeah. So,
Solve the fraction.
yeah, get rid of the fractions basically. Now, what should I do here to get rid of the fractions? Yeah?
You get the least common multiple.
Yeah, which basically amounts to multiplying by,
40.
yeah, we could multiply by 7 first, or a bigger number. We can do it in steps, or we can try to do it all in one go. You're right, if I multiply by 42, I will cancel the 7, I will cancel the 6, I will cancel the 2, but I won't cancel the 3. Okay.
Sure. If you cancel.
Now I will cancel the 3. If 3 goes into 42, of course. I was thinking of 41. So yeah, 42 will be perfect here. So I'll multiply everything by 42. So multiplying all of these by 42. Right, okay. How many times does 7 go into 42? 6. So you're really left with 6 here, but you have a 5 as well. So 6 times 5?
Minus 30.
Minus 30. Okay, now 3 goes into 42. What's it? 14 times. Yes, 14 times. But there's a 2?
Minus 28.
Minus 28. Okay, and then 6 into 42, we've kind of seen it already. It's 7 times, but there's a 5 here.
It's not 28.
So, well,
Minus 35x.
wait, hold on. If people are speaking at the same time. So what were you saying? Did I type
Where's
right?
the x here? Yeah.
There's no x there, thank you. And then here's where the x is. So what were we saying? 6 into 42, 7 times 5, 35. Okay, and then 2 in the 42, 21 times 3, 63. Now, also, I don't really like all these minuses here, and in fact, minuses in everything. So what would be a smart thing to do now? Yeah, multiply everything by minus. So that becomes positive, 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 and positive. Now it's just like the previous problem. So I'll take this to the left, and I get 30x minus 35x. That's minus 5x. And then take the 28 to the right, I get 63 minus 28. Yeah?
Minus 30.
So here, well, it'll be a positive number. What would it be? 35. 32 and 3, 35. Yeah, minus 5x equals 35. So final line now, answer is minus 7. Now that's fine if you don't have a calculator, or well, if you do have a calculator, it's all right. But the way you suggested of just grouping things together works perfectly fine as well. So the second way to do it would be just to group things together as normal first. So I would start off by saying minus 5 over 7x plus 5 over 6x equals minus 3 over 2 plus 2 over 3. That's the same one, isn't it there? So I took this to the left and it became positive, yep. And I took this to the right and it became positive. What would I do next though on the left?
Same denominators.
I could do that, but if I want to try and avoid dealing with fractions and just let the calculator do the work, what else could I do?
Just add the
I could, but I'm thinking something else here. What's in common to both of these? The x's, or on the 5 too, but the x is what I was looking for here. What I can do here,
multiply.
just take the x out. I just took the x out here. What's the name you might give to something like that, that you can see in both terms?
Factor.
Yeah, common factor, or just a factor. We say the x is a factor here, so I can take it out. And the reason I did that is because, you know, it looks nice and easy now. It's like ax equals b. You know, number x equals number. So what would I do now as my last line?
Multiply.
Yeah, oh well, divide. Bring this piece underneath here. So I get x equals minus 3 over 2 plus 2 over 3 all over minus 5 over 7 plus 5 over 6. Okay. Now we can take our calculator out, and of course we'll pretend we did that and we'll type that into our calculator and out should come minus 7. Okay. Right, there's still one more to go, but I'll just give you a minute to write this method down. And to be honest, you know, since you're allowed to use a calculator for the exam, and like I said before, the exam is, you know, you don't have much time in it, it's probably best to do it this way. It's the quickest way, and your calculator's doing a good bit of the work at the end. So please make sure you write this method down as well, and then we'll look at maybe one or two more examples. Now, some people came in late, so who needs a book? Okay. Right. So firstly, your name? Ahmed. We already have two Ahmed, so give me a second name. Ahmed something.
Al-Bahabi.
Al-Bahabi, okay. Right. Who else now? Okay. Your name? Great. And then your name? Mohammed. Now you weren't here on Friday, were you? And this is your first day? Okay, yeah, so I don't remember seeing you. Alright, so you're Mohammed then. Right. Now, Sammy, do you have the homework from Friday? No, okay. And then, Ahmed,
Yes.
do you have the homework from Friday?
Yes.
Okay, let's have a look. Okay, good job, okay. 1, 2, 3, 4. Great. Now, those people who are late, you don't get marked as present for this class, okay? And that's worth keeping in mind for everyone else here. So if you're late for class, you don't get attendance for it. Okay. Right. You still need a minute to write that down, yeah? Okay, looks like nearly everybody has this taken down, so I'll go to the next example. So, right, next example now. And this one now, you might say that it's not really a linear equation, but then at the same time it kind of is, because when you look at it here, 7x plus 5 over 3x minus 9 equals 2. Now it's linear insofar as the x has just a power 1 on it, but it's not really truly a linear equation. But the reason I included this in this worksheet is because in just one line I can change it into a linear equation. And that one line is what exactly? Well, it's just bringing this piece up to the top. Does anybody know the name of this piece here? That's the process, yeah, but actually the name of this piece here. What is it? Yeah, that's it. Denominator. Okay, denominator. And the piece on the top? Also close, not nominator though. Numerator, yeah, that's it. So denominator on the bottom. Okay, we don't really, I mean, you would see the word denominator a lot more than you would see the word numerator, because usually we're worried about the denominator. Why might we be worried about the denominator? What might concern us about the denominator?
It's a fraction.
If it's not, well, not if it's a fraction. What could go wrong with the denominator? What could give us a headache? No, that's okay. Yeah, if the denominator is 0, that's a problem. Okay, so for this question here, we'll say at the beginning that the denominator is not 0, and it's important to keep that in mind. And I'll show you maybe later a reason why it's important to remember that the denominator is not 0. So it is a good habit, good practice to write at the beginning here something about the x, that the x is not equal to 3. Now, of course, in the exam, you don't lose any marks or gain any marks by doing this, but it's good to do, because in more complicated problems where you have many answers, you will lose a mark if you give one answer that you're not allowed to use. So let's just imagine here that this question had many answers and one of the answers was 3. Well, we should not include that in our final answer, because at the beginning here we're saying that x can't be 3, because this doesn't make any sense if x is 3. Okay, so for now, really it's just about getting into the habit of remembering when you write a denominator, when you have a fraction, you should write in that x is not some value, so that this won't be 0. Okay, it's just a good habit to get into, and at this stage you won't lose or gain any marks. Like I said, just a good habit to get into. So now we can go ahead and solve it. If this is not 0, and that's a big if it's not 0, I'm allowed to bring this up here, or as what somebody said, I think you said cross multiply is cross multiply is the name for it. So bringing that up there, I get 7x plus 5 equals 2 times 3x minus 9. Okay. Now, what should I do next? Something's a little bit different here from the previous ones. What's next? Yeah, I should multiply out, or another way people describe it is expand or open the brackets on the right. So the left is unchanged, but on the right I have 2 times 3x, which is 6x, and then 2 times minus 9, minus 18. Now this is exactly the same as what you've seen before. The 6x comes over to the left, 7x minus 6x is just one plain old x, and 5 goes over to the right, minus 18 and minus 5, what's that, minus 23, isn't it? Yeah? And then that's it, that's the answer. Okay, we'll do one more example now, and then I think that's plenty of examples to get you going. So just write that one down. Okay. I should actually say something about the book here. This here is semester 1 workbook, okay, and this is, you are my 10th or 11th IFY. So every so often I completely change the workbook or improve it. So this is version number 3 of the workbook. And you're the first group to use this new version of the workbook. There is about 3,000 questions in here. And when you make 3,000 questions, there's a possibility 1 or 2 of them might be wrong. So if you spot a mistake, just let me know so I can correct it. Okay? Right, we'll look at one more example now, probably our most difficult example. Okay, so let's say 9x plus 4 over minus 6x plus 4 equals minus 9x minus 5 over 6x minus 2. And again, let's see here. If I look at this piece here on the right, I have to say x does not equal 2 over 3, which is 1 over...
So Stephen, are you
Yes.
all the students together, or
Science and engineering I have together
Just
now,
science and
and business are in a different room.
business different?
Yeah.
Okay, thanks.
X is not equal to 2 over 6, which means x is not equal 1 over 3. And then this one here, 6x does not equal 4, so x does not equal 2 over 3. Okay. So there are 2 values of x I'm not allowed. So if I get that as an answer, then I can't use that as an answer. What do I do here? Well, in fact, I do the same thing as before, but I have to do it twice. So this part gets brought up to the right here, and then this denominator gets brought up to the left. So I get the following. 9x plus 4 times 6x minus 2 equals minus 9x minus 5 times minus 6x, squeeze that in, plus 4. Now, just like in the last one, I have to open, I have to expand here. But the complication is it's on both sides, and in both cases, there's 2 things multiplying. So if I look on the left here, I have 9x multiplies 6x, and it multiplies minus 2, and 4 multiplies 6x, and 4 multiplies minus 2. So I actually have 4 pieces on the left. And likewise on the right, they multiply, and then 5 multiplies that, and then 5 multiplies the 4. So you get 4 pieces on the left in total and 4 pieces on the right. So you get 8 pieces in total. So let's look at what we get. 9 times 6, what's that, 54. X times x? X squared. Now 9x times minus 2, minus 18, x, and then 4 times 6, 24x equals minus 8. Sorry. Minus 8 equals, now I won't have space to write in here, so I'll go to the next line. Minus 9x times minus 6x is 54x squared. Minus 9 times 4 is minus 36x. Minus 5 times minus 6 is plus 30x. And then minus 5 times 4, minus 20. Now, if I bring all the x's to the left and the non-x's to the right, I get 54x squared minus 54x squared minus 18x plus 24x plus 36x minus 30x equals 8 plus 20. And you see, that's great because they cancel. Now, I deliberately made all these questions in such a way that the x squareds would cancel. Did I make a mistake? Sorry. Oh, sorry, because the minus 20 is already on the right. Thank you. Thank you. It's good to see you're awake. On the left, the x squareds cancel. And I've made all the questions so that this will always happen, because like I said, we're looking at only linear equations today. So we don't want to consider anything that might not be linear, like x squared. So that's good. Now let's see. 24x minus 18x, what's that, 6x? Yeah? That's right, isn't it? And then plus 36x. Well, 36x minus 30x is another 6x, isn't it? And then on the right, 8 minus 20, what's that, minus 12, isn't it? That's great, because I can see on the left I get 12x, and on the right I get minus 12, so I'm finished up here by saying x equals minus 1. If I go back to the start, that's allowed, okay? So this is the answer then. Okay, that's probably a lot for you to write down, so I'll just give you a moment to write that down. And if you can squeeze this in on one line in your notebook, that'd be great. Yes. You need to go up, is it? Yeah? More? Here? Okay, it looks like you actually have this taken down. So, we will, or well, I'll help you if you get stuck, but I'd like you to do some questions here to practice from this, and then I'll tell you what your homework is from this. So if you can circle these to do now, okay, I'll give you about 10 minutes to try these to make sure you're happy with them. Number 1, B and C. Number 2, B and C. Yeah, number 3, B and C. And then number 4, B and V. B and V. V. Yes, V. So there's 8 questions for you to do. You should get them done in 10 minutes, especially if you have your calculator, okay? So you might need to use your calculator for this.